cosines, which is another way to solve for information in a triangle, sides and angles like we did yesterday. Except yesterday, to use our law of sines, we needed to know both parts of one letter. The law of cosines is what we do when we don't know both parts of one letter. The law of cosines comes in 3 different forms. Yesterday I told you that you didn't have to memorize the law of sines, but you probably would know it by the time you got to the end of your homework. Again, you don't need to memorize the law of cosines, and you probably won't remember it. By the time you get to the end of the homework, it is messy than the law of sines. Okay, and it will be provided to memorize it. But what I do want you to notice about it is that the letter is over on the left-hand side. That is the big letter. Okay, whatever little letter is over on the left-hand side by itself, that matches the big letter that's inside of the cosine. And the other stuff is the other. So on the quiz, I will print one of these 3, and you need to know that we're allowed to shuffle it around so that whatever little letter is by itself, the big letter is inside of the cosine, and the other stuff is the other letters. Okay, so on the quiz or the test, I'll print the first version, and you need to know that you can kind of switch out A's for B's and C's and stuff. So we're going to set up the problems the same way we did yesterday by listing out what we know and need to know. So in this one, we know side A is 12, side C is 16, and angle B is 38. We do not know 2 angles, so we cannot subtract from 180. And we don't know both parts of one letter, so we can't use our law of sines. So this is where the law of cosines becomes necessary. For this question, since what I'm solving for is angle B, or rather side B, I'm going to use the form of the law of cosines that has that little b alone. So that's the second one that's printed on your paper that has the little b alone. That puts the big B inside of the cosine, and the other stuff is the other letters. So then we fill in what we know. We don't know little b, but we can fill in A and C, A and C, and the cosine of angle B.
No, it's page 6, right?
Plus 6. Is it plus 16?
Plus 16. We're plugging in the numbers from the question. So it's the 16. Right? So we plug in the stuff that we're given to the formula. Then everything that's on the right-hand side is a value that can be plugged into the calculator. There's no variables over there on that right-hand side. So we can plug that whole thing into the calculator in one piece. So I can type in 12 squared plus 16 squared minus 2 times 12 times 16 times the cosine of 38 all at once. And I get an answer of 97.4. But I run into a problem with that being my answer, because that would make it by far the biggest side of this triangle. But 38 cannot be the biggest angle. If 38 is the biggest angle, we're not adding up to 180. So this can't actually be my answer. Does anybody see why this is not my answer? Because that equals b squared. So to get our final answer, we need to square root that. This is a super common student mistake. Students get excited about like having a number, so we think that number is our answer. But that number is not your final answer because that equals b squared. So we need to square root that to get our final answer. So when we square root that, we get about 9.9, 9.86. Which would then make angle B be the smallest angle, which makes a little bit more sense. Now we have 2 more things to solve for, but we will of one letter now. So now we can go back to our law of sines. So the good news is if you understood yesterday's homework, great. Every problem's going to end the same way doing yesterday's homework. If you didn't understand yesterday's homework, great. You get an extra opportunity to practice it. Because every one of these questions, we're going to end up using our law of sines as well. So our law of sines, we set up with a matching pair, sine of the angle over the side, equals. Now, it matters what angle we go for first. You must always go for the smallest remaining angle. Reason is, in our calculator, when we solve for an angle, we have to do that second. So we're going to have to do a second sign here. The calculator is programmed to only give you acute answers when you do a second sign. So if the true answer is supposed to be obtuse, the calculator will give you an incorrect answer. It won't give you an error. It will give you a wrong answer. So it is important that you always go for the smallest remaining angle. So do I want to go for angle A or angle C?
Angle A.
Angle A, because 12 is smaller than 16. So I want to go for that smallest angle. We're going to multiply both sides by 12. As we did yesterday, type into the calculator 12 sine of 38 divided by 9.9 gives us about 746. But that's our sine of A. So we need to do a second sine to get that A is about 48. Oops. Ah. And how do I get my third angle?
You add A, B, and then
Add what we have and subtract from 180. Always subtract from 180 when you have two angles and you're looking for a final angle. Do not go through a law of sines again. You might get a wrong answer, and it's a lot more work. So just take the two angles that you have and subtract from 180. And this answer was a bit obtuse, so that means if we had gone for it instead of the other one, we would have gotten a wrong answer. The calculator would have told us that angle C was 86. Okay, so in this case it wouldn't be super wrong, but it is wrong nonetheless. So always make sure you go for your smallest angle. Going to set up this problem the same way that we did the last one, listing out what we know and what we need to know. So this time we have B is 22, little c is 19, and angle A is 81. So we do not have two angles to subtract from 180. We do not know both parts of one letter, so this is where the law of cosines is necessary. The law of cosines is always the last resort, so always check for those other two things first. Do I have two angles, or do I have one letter? If not, then we need our law of cosines. So that's the first one that's printed on your list of law of cosines. So we plug in what we have. Everything on that right-hand side is a number or value we plug into the calculator. Variables over there, we can plug in that whole thing all at once. And when I do that, that gives me about 714 point some stuff, which would seem like kind of a crazy answer for a side of the triangle there. And that's because it's not our final answer. We still have to take our square root to get down to our final answer. So taking the square root of that last answer gives us about 26.7. Now we have both parts of one letter, so now this problem turns into a problem from last night's homework. Set up sine of angle over its matching side. We always want to go for our smallest one first. In reality, in this question, it wouldn't make a difference because since side A is the biggest, that means angle A is going to be the biggest and neither one of our remaining angles can be obtuse then. So in reality, in this question, it doesn't matter, but as a good habit, just always go for your smallest one first because sometimes it does matter. So which one is going to be the smaller one?
19.
The 19 gives the smaller one, so that means that we're going for C. So then we multiply both sides by 19 and type in that left-hand side of the calculator, 19 sine 81. Make sure you close your parentheses. We talked about that yesterday. Divide by 26.7. You get about 0.703 is the sine of C. So we need to take our second sine or inverse sine to get about 44.6 or 45. For angles, we can go to the nearest whole number. Oh, thank you. Yes, that's supposed to be C. So then how do I find angle B?
Add A and C and
Yep, since we have two angles, we can subtract the ones that we have from 180, and that leaves 54 left over. Now, if I had accidentally written them in the wrong place and not noticed, I could have realized I had a problem when I go to do my double check. Make sure that your biggest angle goes with your biggest side, your smallest angle goes with my smallest side, and I would have run into a problem. So then I would have gone back and looked at my work and hopefully figured it out there. Okay. Questions? We have one more situation to look at then, and that is the case where all we are given is sides, no angles at all. So we don't have two angles, so we can't subtract from 180. We don't have both parts of one letter, so our law of cosines is necessary. We always want to go for our smallest angle first, so which angle am I going to go for? A. So that means I want to choose the law of cosines version that has the big A in it. So that's the and we're going to plug in what we know. In this problem, everything on that right-hand side is not a value that can be plugged into the calculator because our variable is over there. So in this question, we are going to have to calculate three separate chunks. The first thing we're going to calculate is the left-hand side all by itself. So 8 squared is 64. Then we're going to calculate the squared stuff, 18 squared plus 13 squared. And then we're going to calculate the multiplied stuff in front of that cosine. So 2 times 18 times 13. Now I want to do a little side note problem here. You don't have to write this down if you don't want to. You really know what to do here if the numbers weren't so gross and if it maybe didn't say cosine in it. But if we had something like, let's say 10 is equal to 8 minus 6x, what would I do first to solve that question? Subtract 8, right? Early in Algebra 1, it's a common mistake for students to want to take that 8 minus 6x and make it into a 2x. Early in Algebra 1, we try to put that kind of stuff together, but we kind of learn through time, can't do that because they're different. One of them has a variable and one of them doesn't. So then we would subtract 8 to begin the solving process in this question. It's actually exactly the same as that equation. We have a number equals a number minus a number times a variable. So this is the same exact situation as that other one, just our numbers are a whole lot bigger and messier, and instead of being an x, it's a cosine. But we have the same thing here. You cannot do 493 minus 468. Eventually, if you do that, you will get an error in this question. Your calculator will say error. Okay, so we cannot do that here. We have to solve this problem like that other one, subtracting 493 from both sides.
Can you do plus 468?
You could add the 468 over to the other side, but then we're still not any closer to having the variable alone. So it's better to do the 64 minus the 493. So it gives me negative 429 is equal to negative 468 cosine of A. What should I do next in solving the question? Divide by negative 468. So I get 0.916 repeating is the cosine of A. And how do I find out what A is? Second cosine. The inverse cosine of that decimal answer gives us about 23.5 or 24. This is our final case for solving, and as is kind of typical in math classes, as we progress through different cases, the problems tend to get a bit messier. So this is as bad as it gets, and there's no law of tangents, so we don't have anything to talk about with that. But this is the messiest problem. Are there any questions on that process? Mm-hmm.
How come you didn't subtract before and then just get 64 equals cosine of A?
How come I didn't subtract what before?
493.
Minus the 468?
Yeah, does the cosine go with that?
Like that, we can't do 8 minus 6x because one of them has a variable and one of them doesn't. So we can't subtract those two. We have to subtract over to the other side. So now at this point in the question, yes?
Couldn't we have subtracted the 64 to the other side and added 468 cosine of A to the other side?
That would work. It's 2 steps instead of just 1 step, but it would work.
Okay.
At this point, we now know both parts of one letter, so we can go back to our law of sines. So I can say sine of 24 over 8 is equal to, always go for your smallest remaining, so what one am I going for here? C. Do sine of C over 13. Then we multiply both sides by 13. And on the calculator, 13 sine of 24, and again, make sure we close those parentheses, divided by 8, gives us about 0.66. And second sine of that answer gives us about 41. We have 2 angles. How do we get the last one? Add and subtract from 180. So it leaves 115. We can do our double check that our smallest is A for both and the biggest is B for both. A couple of warnings. Again, be careful in your solving of this equation that we calculate 3 separate chunks, subtract off that front number, and then divide. A second warning is be very careful that you're pressing the right trig button at the right times. So yesterday we used the law of sines for everything, so we only had to worry about hitting the sine button. But today we're mixing and matching. So sometimes we're doing cosines, sometimes we're doing sines. Make sure you're hitting the right button at the right times. Okay. Let's try one more example of this type. So we can begin by listing what we know and need to know. We have all sides, so we have to begin with our law of cosines. What one do I want to go for first? A. So we're going to use the form that has the big A, which means that it's the form that has the little a alone. So we plug in what we have. Calculate in 3 separate chunks. The 8 squared by itself, the other stuff squared, and the multiplication. And again, it's tempting, and some of you will probably make this mistake. The nice part about making this mistake is the calculator will give you an error, so you will know you've done something wrong. You cannot do 244 minus 240 and make this 4 times the cosine of A. You will get an error eventually in the question if you do that. Okay, we cannot combine those two terms over on that right-hand side. What do we need to do?
Subtract 244.
Subtract the 244. So it leaves us with negative 180 is negative 240 cosine of A. Be careful you don't lose those little negatives. They're easy to lose. Divide by the negative 240 gives us 0.75 is the cosine of A. And when we're solving for an angle, we have to do second. So second cosine of 0.75 gives us about 41.4, or we can just round that down to 41. Now we have 2 parts of 1 letter, so now we can go back to our law of sines. Sine of angle over its matching side. And do I want B or C first? C first. Go for the smallest remaining first. Multiply both sides by 10. So into the calculator, 10 sine of 41. And again, make sure you close those parentheses after that 41. Divided by 8 gives about 0.82. Which is the sine of C. So here we need a second sine. So again, a warning to make sure you're pressing the correct trig buttons at the right times. Sines when we need sines, cosines when we need cosines. We get about 55 here. Whenever you have 2 angles, do not do trig. Subtract from 180 for the remaining angle, 84. Questions? Yesterday we talked about one way to find area of a triangle. This is another area of a triangle formula. Again, you don't need to have it memorized. It will be provided to you on the upcoming quiz. This formula has 2 parts. It has our actual area part, but then in that area formula there's a letter S. And so then we have a separate equation that defines for us what S means. S is the semi-perimeter. Semi means half. Perimeter is when you add up around the edges of a triangle. So the semi-perimeter is half of adding up the edges into our area formula. So this formula can be used when we know all 3 sides of a triangle and no angles, and none of those sides happens to be the height. So first thing we calculate is S, which is half of the perimeter. It does not matter what order you add those sides in, because adding is what we call commutative. It doesn't matter what order you add in. You get the same answer. So we get that S is equal to 56. And then we plug that into our area formula. And that area formula said that we have the square root of s times, and then s minus each one of the sides in turn. And again, it does not matter what order you do them in, as long as you do each one. You can type that entire thing into your calculator if you use parentheses as I wrote. So if you open and close parentheses as is written there, you can type it all in at once. And I get about 427.5. This area formula is useful for like land surveying. If you had a triangular plot of land, surveyors use their tools to measure distances and lengths, not typically angles. So they could know how long each side of a triangular plot of land was and use this formula to calculate then how big that plot of land is. So one more example of the same type of thing. We begin by finding S, which is half of the perimeter, or the sum of the sides. And I get 21.5 for S. Don't round it off. Okay, it shouldn't be a gross decimal. It should either be a whole number or a 0.5. So if it's a 0.5, just let it be a 0.5. Don't round it off. That will change your answer. So then our area is equal to the square root of S times S minus each one of the answers in turn, or each one of the sides in turn. And you can type it all in at once if you use parentheses around each one of those subtractions. I think about 83 for this one. Your homework is in your packet again. There are 10 questions. It is important that you take notes of. On number capital B, it should be a lowercase b. So on number 4, on the homework there, make sure you change that capital B to a lowercase b. It is supposed to be a side, not an angle. You will get very strange answers if you leave it as the angle.